Hello, everyone. I'm Professor Nguyen, and welcome to Chemistry. Okay, for today, I would like to continue our discussion about solutions for Chem 100. It's Chapter 5. Okay, last time we talked about solutions, we went through quickly about definitions, the concentrations, percent concentrations, part per million, part per billion. We also went discuss about molarity, the definition of molarity, and ion concentrations and dilutions. Osmosis was the last topic we talked about, and there's a lot of good example here that we haven't gone over in details. Okay, we quickly mentioned electrolyte and some important definitions. Okay, so the purpose today is so that's give you an overview what need to be done, what we need to know for these chapters. And the purpose today is to get into the detail and discuss the specific example. What do we need to get done? Okay, here it is. Let's start with concentrations. Percent concentration is very popular um, concentrations that you probably see every day. Okay, here's a good example. Now, if you um, make a solution with a total volume of 500 ml milliliters, and it has 25 gram of salt in it, sodium chloride, what is the percentage? What is the percent salt? Okay, what you do, you always take the solute, which is a smaller amount, divided by um, the volume or mass of solution. In this case, we have the volume of solution, 500 milliliters. You divide, this is the ratio, you multiply it by 100. It's supposed to be 100%, but we don't want to think 100% is 1. Okay, we don't want to think that multiplied by 1, it's going to be the same numbers. No, we just multiply it by 100, and the percent size is going to be there. So you do that, you should get 5%. So I want you to take out a calculator and give it a try. Make sure you get the same answer. And sometime, if you got a different answer, send me a message, and we can clarify that. Okay. Sometimes I make mistake too, and I definitely appreciate that. Even you make mistake, there's nothing to worry about. We all make mistake, especially with numbers. Trust me. Okay. Now, okay, that's percent concentrations. Moving on to part per million. Okay, now we got lead. We're not supposed to have any lead in water, but let's say we have 0.525 gram of lead in 2,000 milliliters of solutions, say water. That's 2 liters. It's about 2.2 quarts. Okay, 0.5 gram of lead, probably lead ions. Okay, what is the part per million? Okay, we take the mass of lead divided by 2,000. Remember, volume has to be in milliliters. If it's in liter, you convert it to milliliters. Remember, 1 liter equal to 1,000 milliliters. Okay, so if you go for milliliter, you multiply by 1,000. All right, you divide it by 2,000. This is already given to us in milliliter. Multiplied by 10 to the 6. That's what we call part per million. 10 to the 6 power is a million. Put in your calculator, round it off to 3 significant figures. We got 263. ppm stand for part per million. And that's a lot. Okay, so that's why when we do something like sensitive, like lead, very toxic, right, at high concentration, we want to use ppm. So that way the number looks significant. Okay. If you do percentage, it's going to be real small. All right, like 0.2 or whatever percent. Okay. All right. Now, how about part per billion? Okay. Again, we're not supposed to have lead in water, but let's say we got a very tiny amount. Say, oh, that's nothing, right? 0.00025 gram of lead in 1 liters of solutions. 1 liter is 1,000 ml. Okay. Now, if you take that, divide by 1,000, that ratio is really small. Multiply it by 10 to the 9, that's a billion. And that gives us 25 part per billion. Well, that's very significant, 25. That's definitely will catch somebody's attention. If you do percentage, it's going to be really small. Okay, so that's why we do this, part per billion. Okay, so those are 3 good examples about percent concentrations, part per million, and part per billion. We good? Okay, hope to see you again in the next video. We'll talk about molarity and dilutions plus some other calculations. Thank you guys.